if you yeah, okay, I don't have anything else to say here. Yes, that's it. The isolation is already too high, so you don't need to worry about the small phase differences that cause the isolation go up and down as the time progresses. I believe this is the reason why I input here a clean sinusoidal signal, and at the output port, especially at the higher frequencies, I get a more distorted signal. I think the phase difference between these ports causes this distortion in the other port. But we will use it as a splitter or as a combiner, so we don't care actually about what kind of signal quality will present at the other port. We care what the quality of signal at the combined port, or vice versa, from the combined port to the two other ports, which is a clean sinusoidal, as is the input signal. So now I have connected this circuit as a splitter. I have connected the VFO directly to the combined port, the input port if you use it as a splitter, and I have connected the two ports, the F1 and the F2, into the scope. I have not used the same lengths of coaxial cable for the two ports, so let's see what's measured on the scope. These are the two waveforms at the two outputs of the splitter at 7 MHz, and you can see that they are about the same level, 552 millivolts and 535 millivolts. There is a slight difference, and I think this explains the slight difference we have found between the splitting of the two ports. I think it was something like 6.02 decibels for the one port of attenuation, and the other 6.13 something, if my memory serves me well from the previous test that we did. You can go back in the video and look for it, verify it if you like. So yes, there is a slight difference in the output amplitudes. So I will set up the spectrum analyzer, the FFT, to actually measure this difference. So this is the FFT screen, and these are our two signals, one on top of the other, and the slight difference here in the amplitude or in the phase. We'll see that later on. This is the middle is the waveform of the FFT function, the subtract function, which subtracts one waveform from the other. So if we switch off the two channels now and see only the FFT, their difference, I'm going to increase the sensitivity a little bit of the FFT. To 40 millivolts per division, and now to 12.5 millivolts per division, and their difference is about 62.5 millivolts, the difference between the two output signals. So now I will try to make the the coaxial cable lengths as equal as possible, to see any phase, if this will change the difference between the two signals due to phase variations. So I've done that. I've made the two cables almost equal. I made one of the two cables using an adapter, because I have two different two small pieces of coaxial cable that when connected in series together, they equal my other coaxial cable that goes to the scope, the other port. And I had to change the adapter also here. So if we notice the difference between the two output ports now, you see there that is much less. We are again at 12.5 millivolts per division, and you can see that there is about, let's say, 15 millivolts of difference between the two signals. Now this shows that there was some phase difference due to the different coaxial cable lengths that I have used for the scope, on the scope. So let's check out the oscilloscope waveforms as well. So here are the oscilloscope waveforms. I am not sure, but I think they have been improved a bit, but I'm not sure about that. It's difficult to measure it on the oscilloscope. I believe that the phases at these middle points have been improved, but I'm not sure. I can't say from the oscilloscope display alone. The FFT shows us an improvement though, a big improvement. So it does matter if you test the splitter using same length of coaxial cables to the oscilloscope or the spectrum analyzer. And here is the FFT combined, the middle line, this one, combined with the oscilloscope waveforms. And here are the same waveforms at 30 megahertz. And here's the difference of the two signals on the FFT at 20.5 millivolts per division in the FFT scale. So it's about 15 decibels, maybe a little bit less than on 7 megahertz, just a little less. So these were all the tests I did in the splitter, and I believe it works quite well for its simplicity. And I think that's the end of this video. Thank you very much for watching. Here is Kostas, Sierra Victor 3 Oscar Romeo Alpha, and make sure you check out my website at qrp